Welcome to AELTS News. I'm your anchor, Lee. Today, we'll be sharing the latest updates from AELTS at Kyung University. Did you know that a new course called the Language Trends through Statistics has been introduced in our department? Some students might already be familiar with statistics, while others may not be comfortable with it. In this course, students as reporters analyze the various language trends in our daily life and apply different statistical methods based on what they have learned. Let's take a closer look. We will now connect with our first reporter, Park Min-young.
Hello, this is Min-young Park reporting from AELTS News. Right behind me is the class 통계로 보는 언어트렌드. Here, students are learning how to interpret language phenomena through numbers. It's more than just a lecture. Hands-on, data-driven analysis that brings linguistics and statistics together.
I signed up for this class thinking linguistics plus software sound fun, but I actually walk into standard deviation, p-value, and put on better with JASP. The first method I learned here was a t-test. A t-test check whether the difference between the two groups is statistically meaningful or just a random constants.
Same students, two tests. This is where we use a paired sample t-test. It compares one group measured twice, before and after something changed. Just one group and one score. And known average? That's when we use a one sample t-test. For example, if students in this class score 72 on average, we might ask, is that really different from the national average of 17? If we are comparing two separate groups, say Group A and Group B, that's an independent sample t-test. It tells us whether a difference between those two groups is meaningful. We choose between paired one sample or independent sample t-test, each helping us see different kind of story hidden in the numbers.
Fine, we've seen t-test as the first statistical analysis to compare the groups. But in statistics, all what can you do is just comparing. Isn't it possible to see the relationship between two groups? Let's ask our second reporter to see what correlation is.
Hello and welcome to Language Trends through Statistics. I'm your host and today's keyword is correlation. In plain language, correlation tells us how strongly two variables are related. For example, when one variable increases, does the other increase too or decrease? We usually express this with a number between -1 and 1. A correlation of +1 means a perfect positive relationship. A correlation of -1 means a perfect negative relationship. And 0 means no relationship at all. Let's bring it to life with an example. Imagine we look at how many hours students study English and compare that to their TOEIC scores. We might find a positive correlation, say R equals 0.65. That means, in general, the more someone studies, the higher their TOEIC score tends to be. But here's the important part. Correlation is not causation. Just because two things are related doesn't mean one causes the other. Maybe students study more because they already aim for a high score, not the other way around. So, why does correlation matter? Because it helps us spot trends in language learning and guides us in forming smarter research questions. Statistical literacy lets us go beyond guessing and start understanding. This has been your Language Trends through Statistics update. Stay tuned, we'll be back next time with regression.
In the Herculean Marathon, your choice of book might tell more than your shopping list. Back in the 1960s, sociolinguist William Labov conducting a groundbreaking study in department store to examine how people pronounce one particular sound, the post-vocalic R, as in the fourth floor. Excuse me, could you tell me where the women's doors are?
On the fourth floor.
I beg your pardon?
A set is on the 4th floor.
Labov asked the same question in 3 department stores, Saks, Macy's, and S. Klein, representing different social classes. He found that the clerk in higher class store, like Saks, were more likely to pronounce the R in 4th floor, especially when asked to repeat themselves. But was this just coincidence or a pattern?
To find out, we use a chi-square test, a statistical method used to determine whether 2 categorical variables are associated. In this case, the 2 categorical variables are store type and whether the R is pronounced or not. The test compares the observed frequencies with what we would expect if there were no relationship between the 2 variables. To run this analysis, we will use the statistical software JASP.
Here's the analyzed data, called contingency table. The count shows that how many clerks in each store did or did not pronounce R in 4th floor. Below that, we see the expected count, what we'd expect if store type and pronunciation had no relationship. And below expected count are standardized residuals, indicating how much each cell's observed value differs from expected counts. If they're bigger than plus minus 2, the difference is likely meaningful. As we can see, Saks and S. Klein stands out. Saks, which represent the higher class, had more R used than expected, while S. Klein, the lower class, had much less. This tells us how people pronounce may be different depending on their social classes. Here are the results of the chi-square test. At first glance, the table may look complicated, but we only need to focus on the 2 key values, the p-value and Cramer's v. First, the p-value tells us whether the result is statistically significant. If it's below 0.05, we can say the difference is unlikely to be due to the chance. In our case, the p-value is less than 0.001, which means the difference is statistically significant, not just random. Next, Cramer's v shows the strength of the relationship, called effect size. Our value is 0.564, which indicates a strong association between store type and our pronunciation. So, what does all this mean? The way clerk pronounces R clearly depends on which store they work in, and by extension, the social class of their customers.
In SLA and sociolinguistics, this supports the idea that speech isn't just about sounds, but it reflects identity, class, and context. And with the help of the chi-square test, we can make the invisible patterns in language visible. For AELTS News, I'm Sang-Kwon, reporting from New York.
Great! With correlation and chi-square, we can easily see whether 2 variables are related. But beyond simply knowing the relationship, how much influence they actually have. And when there are multiple variables, how do we know which one has the biggest impact? Let's turn to our reporter who's on site. Yes, I'm currently at Gyeonggi University, where students have just finished their midterm exam. Let's listen to what they are saying.
I studied really hard and I stayed up all night. So I bet I got the highest score.
Just putting in time doesn't always pay off. What really matters is how well you understand the material. I got perfect scores on the weekly assignments, so I think I did well.
No matter how much I study, I think during the test, my mind just goes blank. I think I get a terrible score.
What an interesting conversation. So which of these students had the highest score? To answer this question, we need to examine how much each variable contributes to the prediction. That's where regression analysis comes in. Regression analysis not only tell us whether predictors matter, but also help us understand the strengths of their influence. Plus, it allows us to make predictions. The equation looks like this. In this equation, B0 is the intercept, the expected value of y when all predictors are 0. B1, B2, and so on are the slopes, showing how much y is expected to change when each x increases by 1 unit. Now, let's take a look at the actual data. We learn a regression analysis using students' midterm scores as an outcome, and the predictors were study hours, assignment score, and anxiety score. The results came out in 3 tables. First, the model summary table. It tells us how well the model fits the data. The R-square is 0.659, which means about 66% of the variance in exam scores is explained by the model. The adjusted R-square, which accounts for the number of predictors. Since the difference between R-square and the adjusted R-square is small, this tells us the model is stable and not overfitted. Next, the ANOVA table tests whether the model as a whole is statistically significant. The p-value is less than 0.001. This means that, overall, our model significantly predicts exam scores. In other words, at least one of the predictors meaningfully contributes to the prediction. Now, let's look at the coefficients table. It tells us how each individual predictors contributes to the model. Since all p-values are below 0.05, all 3 predictors significantly affect exam scores. The unstandardized coefficients tells us how much the exam score is expected to change when each predictor increases by 1 unit. For example, for every additional hour of studying, the exam score increases by about 2.17 points. But to compare the relative importance of its different scale of predictor, we look at the standardized coefficients. Here, study hours has the strongest impact on exam scores. In summary, our regression model significantly predicts exam performance, and all 3 predictors matter. Among them, study hours had the biggest influence. So if you want to get a high score in the final exam, go and study hard. Now it's time to show our last statistics. Let's connect to the last reporter.
We've looked at how t-tests and correlation help us explore individual factors. But what if we want to compare more than 2 groups at once? That's where one-way ANOVA comes in. In this study, researchers wanted to know if learning a second language, like English, can improve first language writing skills.
The researchers asked 120 university students from 4 different groups to write a short essay in their first language, which is Farsi. Here are the 4 groups. English major senior and freshman, non-English major senior and freshman. They analyzed the writing using a measure of syntactic complexity.
Did writing in English help your Farsi? Oh, absolutely. I wrote one essay and my mom said I sound like a Shakespeare now. I think that's a compliment.
The researchers ran a one-way ANOVA to compare the mean writing scores across 4 groups. The result is statistically significant, which means the p-value is below 0.05. The English major seniors who are in Group 1 scored the highest score, followed by the other 3 groups. The ANOVA showed that more exposure to L2 writing may actually improve your L1 writing skills. So, second language learning isn't just about communication. It might actually upgrade your literacy skills in multiple languages.
Whether we are trying to figure out many phenomena in SLA, statistics give us a clear way to find patterns. It let us see the patterns behind the complex performance in the real world. This has been Jihae Kang reporting from Kyunghee University campus.
That's all from us with the AELTS reporters. If watching this news drew your attention into statistics and language, sign up for the course now. I'm your anchor Lee. That's the end of our news. Thank you for watching.